Hello, my name is Daniel, and in this video I will show you how to use the algorithm FastQC through a terminal using a computer cluster. In this web page, I'm using the official web page of FastQC. FastQC is a quality control tool for high throughput sequence data, and in this web page you can download the program and also see a tutorial video on how to run FastQC on the Java application on your own computer. Also, you can find further documentation and also example reports like what is a bad sequence Illumina short reads sequencing, as we described on the previous video. So we can now open a terminal to run FastQC. We can prompt the working directory and let's list the subdirectories, and we can list what's inside of these three directories simultaneously: sbatch, EO files, and FastQ. On the sbatch directory, we have a single text file, which is what we will be using to run FastQC on the computer cluster. On the error and output files directory, there's nothing there yet because we haven't run any job yet. And on the FastQ directory, there's a single FastQ file, which contains the sequencing data of this experiment that the plant Arabidotis thaliana was grown on far red light environmental conditions, and they saw how a particular transcription factor changed their binding of the DNA using ChIP-seq data. So let's make a new directory called FastQC, in which we will save the output files of FastQC. We can list these directories and we can see that it is now there. We can now go to the FastQ file that I just showed you to see what's its contents like. We can hear a head and the first 10 lines of the FastQ file, which is whole path. And we can see, for example, this read. It's composed of 4 lines. The first line starts with the @ symbol and it has the identifier and the length which of the sequence read, 36 nucleotides. And now we can see the second line, the sequence itself. The third line would repeat the same identifier with a plus sign. And on the fourth line is the quality associated with those nucleotides positions of the read. We can now explore the sbatch file that I created earlier using the vim text editor, and we can use autocomplete to open the FastQC sbatch file. Here on yellow we have the information that the sbatch slurm will need. And they all start with the pound sign. We first specify that we want to use the bash, and now we have different options here. For example, the job name, I typed FastQC, and the mail type, I'm telling to send all kinds of emails to my email address, and here you will put your own email address. I am using so sorry, if the job fails, it will also be sent to my email. I am using one node and one processor because FastQC can only use one processor per input file. I am requesting 10 gigabytes of memory, which should be plenty for this to be run. Also, perhaps it's a bit overkill. And I'm requesting 1 hour of the computer cluster time. And it will probably run way faster than 1 hour. And the queue or partition I'm requesting to be put on the short queue because it's going to be a fast job. And I'm putting here the path of the error and output files, such as that the output file can be put there, and the %x is a variable that will be replaced by the job name that was specified earlier, so it will be stored as FastQC, and then dot followed by the job ID, or the identifier of the job. Now in this chunk of this block of text is the context of the run, the job name, the job ID, the name of the server, and also the specific time and date when the job started running, and what was the working directory that was used, and how many processors and nodes were used. So all of this is just for documentation purposes. And then I create a directory that contains this path as just text that will be used for the FastQC. Such as it is a more clear way of using FastQC. And I'm using my own directory, and here you would replace it with your own username. And then I'm loading FastQC as a module with a specific version. And then this is how you run FastQC. The syntax is as follows. Well, here you will hear this inverted or backslash in red. That just lets the bash know that it is actually the same line, but you are here dividing it into multiple lines to make it clearer. But in theory, it's a continuous line. So you type FastQC and then -- format, and you put FastQ because the input file will be a FastQ file, and then -- threads number 1 because that's what you specified earlier, because you cannot multi-thread. Then -- output directory. We use the variable directory that we created earlier, and then it will go into the FastQC directory that we created earlier too. And finally, we just put the input file, which is own path. So again, it's the Arabia Italiana chipseq FastQ file that I described earlier. And finally, it just prints the time in which a job finished running. So let's go ahead and run this job. We can exit, and let's go to the directory sbatch. And to run the sbatch, we can clear the screen, Ctrl-L first. And to run it, you type sbatch space and the name of the sbatch file. You can use autocomplete to avoid typos. Press enter. You can see that the job was submitted using this specific job ID. And to check if your job is running, you can type qstat-u followed by your own username. This is my own username. You press enter, and you can hear the information. It has not started running. It is still on the queue. So let's wait a little bit until it stops. It finishes. So it's been some time since a couple of minutes since the FastQ finished running. We can go to list the working directory and now go to the error and output files directory and list what's inside of it. And now there are 2 new files that were created and put there. Let's see what's inside of the one that the error one. We can use autocomplete and just press enter using the more command. And we see that what it contains is just the documentation of how the progression of FastQC through the FastQ file through using a percentage until it reaches 100%. So that just tells us that it ran the entirety of the FastQ file. If we now explore the other output file, we see that it contains the documentation that we ask the sbatch command to the file to report. And what's important here is that it reports the start time and also the end time. And we can see that it took almost exactly 1 minute to run. So that was pretty fast. And now we can change the working directory and we can clear the screen and go to the FastQC directory that we created earlier. And if we list its contents, there are 2 files there. One is a compressed version of the other, which is at HTML. And I have previously transferred those two, the HTML file to my computer, such as I can open it through a web browser. So let's open a new terminal, which is not connected to the cluster, but rather is just exploring my own machine. So we can just use a web browser such as Firefox and just give it the name of the file, and we just press enter. And we can see the results on a normal web browser. And it will contain all of the documentation that was explained on the previous one of the previous videos. And we can see that the sequence is pretty good. It's fairly clean. We can see that the average quality per position of the reads falls a little bit at the end, but overall it's pretty good. So that's how you run FastQC.